Okay guys, so now we are here on the soldering bench, and here is the kit containing all the parts. It says Logic Probe or Logic Tester. Okay, here is the code of it. The diagram was published in a very reputed English magazine, Elector Labs. So the article written by one of their engineers, Clemens Valens. Okay, and it has a diagram. It has a parts list, okay, a full description of the functioning, very nicely described actually, okay. And as you could see, our sample was working just fine, and now we're going to replicate exactly a new project from scratch, okay. This way you are going to have access to build such a project, a Logic Probe you can use every time, and it's going to last for many years. So we take it out of the box, we open the package, okay. Okay. It's actually very nicely packed. Here is the printed board, okay. The magazine Elector, they have their own lab to make these printed boards. So you can order them. Here in the bottom you're going to find the code. So this is the code ordering it, but don't worry, it's on the parts list. If I'm taking a look here on the parts list, it says here the PCB Elector store, and here is the code, okay. So nobody's going to have any trouble to order the printed board. Maybe the components you're going to catch, but the printed board, it's impossible to make at home. So let's open it. Okay, all the parts should be here inside the bag. They come out of the bag. Let's see if there is anything else remaining inside. No, that's all, okay. So we put them aside. And here you have the parts. So the way we are going to arrange everything is going to be exactly like on our sample. And the components are very nicely arranged here. You have the notations for each of them. You just have to identify from the parts list, for instance, the sizes of the resistors, because you know where to place all of them. As for any similar project, we're going to start placing the lowest height components, and these are going to be the resistors, okay? So I'm going to pick up resistors from here. I'm going to start with these ones. If you're still familiar with the marking on the color code resistors, this is a 4 system band. The first two bands, the reds, are 2, 2, and the green is 5 zeros. So when you add them up, you get 2.2 mega ohm each. These ones, if you take a look on the list, they are going to be 2.2 mega ohms resistor R1 and R3. So very easy. We are going to fold and placing them here. So again, R1 and R3, you're just taking a look, the position for the two resistors, okay? So R1 is right here, R3 is right here, so 2 of them are plugged on the board. The board stays because it's very flat. And now we're just soldering we soldered one leg of each, so they won't fall anymore. Now, exactly like we did for the first project, we don't allow the wires to jump to our eyes, so never direct the wires to your eyes. Okay, and I even have the habit to hold them with my hand. Okay, so now we solder the other two remaining terminals. Okay, okay, one was here. Okay, that's good. And the other one was here. All terminals soldered right here. Now we pass to the next one. Okay, we're gonna pick up these two resistors. These are, if you take a look at the colors, brown, black, and orange. It's making 1 0 followed by 3 other zeros, 10 kilo ohm each. Okay, so I'm folding the terminals, and you're gonna find out where these resistors have to be plugged according to the components list. 10 kilo ohm resistors R4, R6. Okay, so we're looking here R4, R6 to identify exactly the position. R4 is right here. And then we're looking for R6 over here. So we take our time to plug them on the board. Now we do the same as we did for the other two ones. We solder each of the two resistors. Then we cut the terminals. Okay, so these ones, check our soldering, making it nicer. That's it. So now we have 4 resistors already plugged. This one is brown, black, and red. This is 1 kilo ohm. Okay, the 1 kilo ohm resistor, if you take a look, is the resistor R5, and additionally we have R7, which is 0 ohms. If you don't have it, all the 0 ohms resistors are actually replacing a piece of wire. They have a black band right here in the middle. Okay, so this is going to be, instead of a piece of wire, is actually a jumper they need on the board. So R7 is somewhere here. And again, the 1 kilo ohm was R5. Okay, R5 is over here. So exactly the same story like we did for the other resistors. We solder the ends of each resistor. And then we cut the excess. Okay, so to make sure, we may need to arrange a bit the soldering. Let's check this one as well, especially if you cut the terminals too short. Okay, from time to time you need to clean the tip. And now what's remaining? There is one more resistor remaining here. And the remaining one, if you take a look at the colors, it's a brown, black, and the green. So this is 1 mega ohm. Okay, So it's 1 0 followed by 5 other zeros. Is making 1 followed by 6 zeros is 1 mega ohm, which is R30. So we're taking a look at the position for the R2 is over here. Yeah, it was just one place remaining for a resistor. And now we solder it. So take your time when doing soldering, especially because you want everything to go nicely. Good. So now we have all the resistors placed. There are no more resistors waiting. Okay. Everything looks fine. Now we look around to find out some other components which are low level. I'm going to pick up this guy. Yeah, it's a very fine printing on this one. This one is going to be a very small capacitor, 82 picofarad. And if you take a look here, is C4. Okay, we're looking for the position of the C4, and is over here. Okay, it's a low component, so we prefer to solder this one right now. Because otherwise it's gonna be more difficult later on to solder it. Be very careful, never direct the pins to your eyes. Done. Okay, now we have a couple of other small capacitors around. We're going to take a look around. This one is 330 nanofarad. This one over here is 470, and this is 0.1 microfarads. So we take a look now, which of them is 470 nano is C5. 470 nano is this one, is C5. Okay, C5, we take a look, is right here. Because they are so tiny, we prefer to solder them one by one to not mess up. Okay, this was C5. Now the next one was 330 nano. 330 nano is C6. Is over here. C6 notation on the printed board. And we can easily place it and solder it. Okay, and in the list of the fixed capacitors there is only one more remaining, this one over here, which is C7 100 nanofarads. So if you take a look, C7 is over here. Very easy job to do. Okay. A bit more work is going to come when you take a look on that sponge. It's protecting electrostatically the circuits. All of them are CMOS. We have to remove the sockets from here, the IC sockets, because we want to solder. Now, let's find out some tricks to solder without damaging, because as you can see, each such socket has a lot of plastic on it. We don't want to melt the plastic, so we don't want to damage the contacts. Okay. First, you have to notice, exactly like the integrated circuits, all the sockets that have a notch. So it's a kind of little opening somewhere in the middle. and it has to be aligned with the notch on the printed board. Okay, so this is one socket. You are going to notice there are two sockets of 16 pin each. These two ones are 16 pin each. You have to be careful because if they are folded, they won't enter properly. So all of them aligned with the notch to my left. Actually all the three of them, but the third one is only 14 terminals, is a bit shorter, and is fitting exactly in the position. Now we turn it on the other side, and to have a good alignment, the first trick is I'm going to only solder one terminal of each. Okay, I'm going to pick up one of the top terminals, solder for each of these sockets. And now I'm turning it on the other side. I want just to make sure that each socket is on the level on the printed board. So I'm pushing it with my hand slightly, and I solder again on the same pin. So by pushing it, it's going to be flat exactly at the level of the printed board. I'm doing the same for the next one. So I make sure it's flat. And again for the last one, I'm going to do the same operation for another pin. Take a look. I soldered the pin on the top right. Now I'm soldering one on the bottom left. On the bottom left of each. The bottom left of each. Now I do the same operation as before. I want to make sure that both ends are flat on the surface. I push on the package and I just re-solder it. Now they're fine. And now, how do we do with the other terminals? Take a look. Let's say I'm starting from the pin on the bottom left. I skip one pin and I solder the next. And I skip the next pin and I solder this one. And I'm skipping one and I'm soldering this one. So by doing this, I make sure that the pins are not overheated, so I protect the whole package. Now I start from the top right. I skip one pin and I solder the next. See? That's what I'm doing. And now I'm passing to another package, to another socket, and I do the same. From the bottom left, I skip one and I solder the next. So during this time, the previous socket on my left is cooling down. I start now from the top right and I do the same. So anytime you have to solder sockets of integrated circuits, this is what you should do. It's a very good trick to protect the integrity of your sockets. It's especially good for people having less experience in soldering. Okay, so you always skip one pin. So now we did this for all the three sockets. Now we come back and we solder all the remaining terminals. Very easy to see which of them were not soldered before. And we follow the same sequence exactly. Okay. So this time I am not skipping none of them because the distance is already set by the previous soldering. The socket is completely soldered. I go for the next. So I soldered the left side, now the right side. So this way, not only I'm not holding the tip of the iron for too long, but I never solder two adjacent pins. I give them time to cool down. Okay. This way, we're doing what again? We're protecting our IC sockets. So now, we have all the three sockets soldered. They look pretty nice to me. Next thing we're going to solder is the very fine sliding switch. You have to be careful about this because that's a very sensitive component, very sensitive to soldering, okay, to the temperature. Okay, so I plugged it, and now it has 8 terminals. I'm soldering one here. I'm taking my time to watch again if it is placed properly. I'm skipping one, exactly as we did before about the IC socket. Now I go back on the top right, I solder one, I skip one. Now I go to solder the remaining pins. Done. Good. In terms of the height, the next one is going to be the buzzer. Please notice that the buzzer has a written polarity on it. Okay, so the positive is in the top, negative in the bottom. So we plug it exactly as is, like that. We put it flat, and now we solder this one as well. Done. We cut the excess. We're almost done. Next are the electrolytic capacitors. These are 2 mm pitch. They're going to fit perfectly in the holes. Please notice that they have a white band where there are 2 dashes. This is the negative, because here all of them are aligned with positive in the top, so the white band comes in the bottom. Okay, so you have to be careful when plugging them in the holes. Watch for the band, the white band, it comes in the bottom. And the last one, white band, comes in the bottom. So just have to align them right to fit in the holes. And now you turn them on the other side and starting soldering. It's exactly as we did for the others. We solder 1 pin for each. So this time there are 3 of them. As you solder 1 pin, you won't overheat the other one and the whole capacitor. Now we do the same on the other one. That's it. And now you cut the excess exactly as we did for the other parts, because if you don't, these ends may touch each other later on. Okay, very good. So now we only have one thing to solder: the pins where we are going to connect the power supply, respectively the wire to take measurements. So it's coming like a compact group of 4 pins. We use the cutter right here in the middle. They can be separated even one by one if you need. Now we just need 2 groups of 2. So we cut right here in the middle. So we're gonna have 2 groups. These are just pins. There is no polarity involved. Okay. So we're going to place them. If they don't align properly, we're going to solder them one by one, no big deal. So 1 pin, we check it stays in the right position. Now we replace the other one. Okay, it's not always easy to convince it remaining. We do this again. Okay, done. I return to the one in the top. Now the remaining pin, everything done. So here it is, in the same position as the other one. One more remaining thing: we place the integrated circuits. Be careful, because we can't place them randomly. So the one which is going here on the left, IC1, you take a look. This is the frequency divider, the 4040. So you look for the 4040. Okay. This is the one. And as you can see, the packages, when they come from the factory, the two rows are not parallel with each other. They are a bit inclined. Okay. So we're going to put them here flat, just pushing a bit. On the other side, we do the same. And if you take a look, the two sides are now perfectly aligned. And we're going to be able now to place it on the socket. So again, this is IC1. Be careful, the notch is on my left. The notch of the socket is also on the left. We arrange it nicely in the socket. So we'll be careful to not accidentally fold terminals. Okay. So first one is done. The second one is easier because there are two packages remaining. Okay. And in the two packages remaining, remember all of them, they come with the two rows inclined, so you have to use the same trick for both packages. But it's very easy to do. One of the packages has 16 terminals, the other one has 14, so there is no confusion anymore. This one comes here. Again, be very careful about the notch. And the last one, the notch now is on my left, and we place it in the socket. Job done. Here it is. That's your project. So far so good? So be careful. Now you have a logic probe. You're going to be able to measure. This one doesn't have lights, only has sound. So you'll be able, by just placing a couple of wires around, like these ones are for the power, is written here on the two pins, VDD and ground, G and D. So anytime you have a double letter, VCC, VDD and so on, this is the power supply. So you can place the two wires, and then you can place the one for the measurement. So ready for use. This is the project. Thank you very much, guys. See you for the next one. Bye-bye.